Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over factoring trinomials, and they're all going to be in this form, x squared plus bx plus c. What that means is the number in front of the x squared is always going to be 1. That's how we're going to start out. But then the b and the c, it could be a plus b, it could be a minus b. Same thing with the c at the end. Always look at the signs in front of those, so it's not always necessarily the plus. To start, why don't we practice our multiplying polynomials and try these 3 examples and then see if you're on the right track. So remember, we distribute, drop that down. The first term, so x, we'll do x squared plus 5x, and then we also distribute the second term, 1, to both terms in the second binomial. So plus 1x or x, and then 1 times 5 is 5. And then we can combine the 2 middle terms, so this will simplify to x squared plus 6x plus 5. Next one, same process, but now we have a 1's a minus, 1's a plus. So we'll have m squared plus 6m, and then the negative in front of the 4, so we'll have minus 4m minus 24. So remember, we're multiplying all of these. And then we can combine again those middle terms, so we get m squared plus 2m minus 24. And last example, now we have both of them are minus, so k times k minus 3k, and then we have the negative 7, so minus 7k, and then the negative times a negative, so it will switch to plus 21. Combine the middle terms, so we have k squared minus 10k plus 21. And I think I did all of those correctly. But this should all be review on your end. We've already done all of this. But now what we're going to be doing, and notice here, trinomials like these, so the answers that we came up with are what we're going to start with. That's the polynomial we're starting with. And we're going to work backwards, and we're going to create the 2 binomials, the binomial times the binomial. That's what factoring is. So notice here we're going to take this big long expression and we're going to then separate it into a binomial times a binomial. All right, so what we have to do this, to factor a trinomial in this form, our goal is to find 2 integers, 2 numbers that will add to the b value being the number in front of the x. And notice I am also boxing in the plus sign. It's a positive 7. So we want to find 2 numbers that add to 7, and the 2 numbers we must multiply to the c value. And if you paid attention, if you've done enough of these over and over, you kind of notice what happens. There's always a pattern. The first 2 terms are always going to be that first term. The last 2 terms multiplied always go to the last term. And then when we multiply everything in the middle, well, that's what cancels out in the middle. So that is why we're looking for 2 numbers that must multiply to positive 12 and add to 7. So you could create a list of the factors of 12. That's where I would start. So we have 1 and 12. Those don't work because they don't add to 7. We have 2 and 6. Again, those don't add to 7. And then lastly, we have 3 and 4. Well, 3 and 4 do multiply to 12 and they add to 7. So what 2 integers have a product of 12 and a sum of 7? 3 and 4. So what we will do is write 2 binomials using these integers and then distribute and check. So we will have x plus 3 and x plus 4 as our two binomials. And then we actually multiply them out and we can check our work. So distribute the x, so we get x times x plus x times 4. And then 3 distribute as well, so plus 3x plus 12. And then we can add those terms in the middle. So x squared plus 7x, it goes back to what we started with. So the nice thing about factoring is we can always check our work and we know whether our two binomials are correct or not. So the factored form of that polynomial is our x plus 3 times x plus 4, what I wrote in pink there. Okay, so there are a couple different sets here. What I like to do is look at the signs first. When we always have that a value of 1, well, we can start out the problem knowing to get n squared, it's always going to start out n times n. Then we want to look at, okay, well, what should the signs be in there? When everything in the polynomial is adding, like we have here and in that last example, well, we know it's going to be a plus and a plus. Same thing with all of these in this set of questions, they're all plus. So you could write down, every single one of these, and I like to just create my parentheses. We know it's going to start out W plus, okay? And then I'm going to show you what we're going to do when we get to the next set where they aren't all plus signs in the polynomial. So our goal here would be what multiplies to positive 20 and then what adds to positive 9. So I would always start with the C value and think of its factors. So 1 and 20, those don't add to 9. 2 and 10 don't add to 9. 3 doesn't go in. 4 and 5, they do add to 9. So 4 and 5 multiply to 20, add to 9. So you can put them in either order. It doesn't matter which one goes in which binomial. And then you could multiply to see if it works. And we'd get n squared plus 5n plus 4n plus 20. I did my distribution without actually showing it. And then 5n, 4n, they do add to 9n, so we know we have that one correct. So our factored form is n plus 4 times n plus 5. All right? And I'll do one more. I'll let you try a couple then. So we want to multiply to 18, and we want to add to positive 9. So we've got 1 and 18. We've got 2 and 9. 3 and 6, and there we go. 3 and 6 multiply to 18, and they also add to 9. So one of them is W plus 3, the other one's W plus 6, and we could check our work. W squared plus 6W plus 3W plus 18. The two middle terms add to 9W, so we know that is correct. All right, you can try number 3 and 4 on your own. I would always start out with your two parentheses. We know everything is addition here, so we know it has to be a plus and a plus. And then what multiplies to 24 and adds to 10, so it would be 6 and 4. And you can check your work. And if you had a plus 4 times a plus 6, it's the exact same thing. And last one, we have y plus in one binomial, y plus in the other binomial. What multiplies to 1? Well, the nice thing about having a prime number is there's only one option, 1 times 1. Now, we can rewrite this because notice that both binomials are the exact same. So we want to simplify, and we'll write it just once with a squared on the outside. Because remember, we talked about that when we multiplied special terms, that means y plus 1 times y plus 1. So we can shorten it up. All right, next set of questions. So now we have the B term is positive and the C term is negative. So how I start these out is if we know the C term is negative, we know one number has to be positive, one has to be negative. That's the only way we're going to get a negative C term in the end. So we're going to start out same way. We know they both binomials have to start with the variable n. One is going to be plus and one is going to be minus. So we want to figure out, same process, what multiplies to negative 18, but then this case adds to positive 3. So when we list out our factors, 1 times 18, we have to think about one of these being negative and adding to positive 3. 2 times 9. So let's say, in this case, let's do this. Since the middle term is positive, we know the bigger number has to be positive. So it'd be negative 2 and positive 9. Those add to positive 7, so it doesn't work. We'll do 3 and 6. Again, like I said, the bigger term has to be positive since the middle term's negative, or positive. So we'd have to make the 3 negative. So those multiply to negative 18, they add to positive 3. So that works out. So then when we place our numbers into our binomials, we have to make sure the 6 gets put with the plus sign and the 3 gets put with the minus sign. And then like we did in the last examples, I would always double check your work. So n squared minus 3n plus 6n minus 18. The middle terms combine to plus 3n, so we know our answer is correct. Okay, let's do it again. We will start out with our two binomials set up. They're both going to start with x's. Again, we have our C term is negative, so we know that one of these binomials has to be plus, one of them has to be negative. And then they multiply to negative 8, but they add to positive 2. So again, the bigger term has to be positive, because the B term is plus 2. So we'd have 1 and 8, so negative 1 and 8, those add to 7. 2 and 4, those multiply to negative 8, and they add to positive 2. So there they are. The 4 should go with the plus, the 2 should go with the minus. And then check your work. X squared minus 2x plus 4x minus 8. Middle terms combine to plus 2x. So we know we're right. Again, try those last two examples on your own. It gets a little trickier now that we have a minus sign in there. So this example, we'd have g plus, g minus, and then multiplies to negative 6, 2 and 3. The smaller number has to be negative so that we get a middle term of plus 1. So multiplies to negative 6, adds to positive 1, so we'd have g plus 3 and g minus 2. And you can check your work. And last one, so we have c plus as one binomial, c minus as the other binomial, multiplies to negative 45, and then adds to positive 4. So 1 and 45 aren't going to work. We could do 3 and 15. Those add to 12, so that doesn't work. We have 5 and 9. The smaller one always has to be negative, so those add to positive 4, so that works. So c plus 9, c minus 5. All right, let's go to the next set of questions. So the next set, again, look at the signs in between. We have all minuses. So similar to the last set, we know that one of the binomials has to be minus. So we're going to start it out, a times a. We know one of them has to be minus and one of them has to be positive because that's the only way we're going to get a negative 3 in the end. So one's a plus, one's a minus. But in this case, what they have to add to is going to be a negative term. So since it's negative in the middle, we know that the bigger factor between the C value, it has to be negative. So 3 is prime. We only have 1 and 3. But like I said, the bigger factor, 3, has to be negative, because that way when we add them, well, then they're going to turn out to -2. So be careful. Make sure the 3 is with the minus, the 1 is with the plus. And then we could check a squared minus 3a plus a minus 3. Middle terms combine to -2a. So we know we're right. Okay? Now, you could kind of guess and check and just put those numbers where you think they belong and then see if it works, and it doesn't, then flip them. But I always like to think of how do we get the middle term to be negative. So I jumped straight below. So multiplies to -63, but then adds to -2. So again, we know this set. 1 has to be plus, 1 has to be minus. That's the only way we're going to get a C value of negative. So let's think we've got 3. They're going to be pretty close because the middle term is 2. So let's go with 9 and 7. The bigger factor has to be negative. That way they add to -2, and that works. So B minus 9, B plus 7. Again, they could be in any order. They don't have to be in that exact order. Okay? Try those next two on your own and see if you can get these correct. So x and x, one's plus, one's minus. 30, it's going to be 10 and 3. The bigger one has to be negative, and then that way those add to -7 in the middle. And number 12, k plus, k minus, has to multiply to 64, -64. So we have 16 and 4, and then the bigger factor, 16, has to be negative, so that those add to -12. You really get some practice with your factors. Last set, notice here we have our last term is positive. And I've been doing pink. So your C value is positive. So we know, same process, that our binomials are both going to start with x, but you may see that positive and think, oh, they should both be positive then. But look at our middle term, our B term is negative, so we know the only way for that to be negative is if we have a negative times a negative to get a positive in the end. So this last set, both terms are going to have minus signs. So what multiply to 24 but add to -11? So we'd have, and you could list them all out, 2 and 12, but all of these, both terms are going to be negative. So -2, -12, add to -14, that doesn't work. 3 and 8, both negative, there we go. They multiply to +24, they add to -11, and it doesn't matter which one goes where. X minus 3, x minus 8. And for sake of time, I'm not checking my work, but I would always check your work. Then you know if you have correct answers or not. So again, if the middle term is negative, the last term is positive, we know then both binomials have to be minus. So what multiplies to +72, but then adds to -17? So 72, 9 and 8. Make them both negative, they add to -17, and they multiply to +72. And again, I would pause here, see if you can figure out these two on the right side. Same process. Now, what's going to happen? In this one, they're both 7s. So again, kind of like that example on the front side, we can simplify how we write this and just write it as x minus 7 squared. And last one. Now what you're going to notice in this next part is they're not always going to be organized in these sets for you. You have to determine which type of scenario it is. And this one would be 10 and 5. Those multiply to +50 and add to -15. Now, like I said, this mixed practice, you need to go through, and I would always start out with your parentheses, times of parentheses, your variable first, but then determine what you need your signs to be. Since the last term, the C, is negative, well, then we know one has to be plus, one has to be minus. If it's a positive term in the end, then they're either going to be both plus or both minus, okay? And then this one, they add to positive 6, so you know that the bigger factor has to be positive. So 8 and 2, the bigger one is positive, and there we go. Those add to positive 6, and they multiply to negative 16. So get some practice on your own with a mixed practice there. Now, down here at the bottom, examples with a GCF. So remember, we've already done pulling out a GCF. This should always be the first step in every factoring we do. None of those examples we did had a GCF though. So look at this example. We have 4k squared, we have 12k, and we have 8. You want to find the GCF, the greatest common factor between those. So 4, 12, and 8, the greatest common factor is 4. Now, not all three of those terms have the variable k. The last term is just 8, so we can't pull out a variable with it. So then we divide all three of these terms by 4. So 4 divided by 4, we just get 1, or just k squared left. 12k divided by 4, we get 3k. And then 8 divided by 4, we get 2. So it's the exact same polynomial. We just pulled out a GCF, a greatest common factor. Now what we can do is factor the polynomial k squared plus 3k plus 2. So we know everything's positive there, so we know that it's going to be k plus and k plus. Now don't forget, because it's a common error I see, don't forget to bring down the GCF with it. So what multiplies to positive 2? The nice thing is that's prime, so we know that 1 has to be 2 and 1 has to be 1, and those add to 3. And then you could check your work. You would multiply the binomials first, and then distribute the 4 out, and it would go back to our original polynomial. I'm going to do one more directly below it, so pull out the GCF. 3, 15, 12, the greatest common factor is 3. The variable is not in that C term, so we cannot pull out a variable with it. And then divide everything. So 3y squared divided by 3 is just y squared. 15y divided by 3 is 5y. And 12 divided by 3 is 4. And then last step, we're going to factor that polynomial. So we know it's got to start with y and y. Now, look at this one. We see our C term is positive. So I would assume, okay, plus, plus, but now look at our B term. It is negative. So we know these both have to be minuses, because that's the only way we're going to get a positive for our C, and then add to get a middle term of a negative 5. So 4, we're going to do 4 and 1 actually, because negative 4 and negative 1 is how we get negative 5. And then do not forget to bring down that GCF. Otherwise, it's not going to be the same polynomial in the end. So there we go. Again, pause here and see if you can do some of these on your own. And we'll check to see if you're on the right track in class.